AP Calculus, Unit 7, Day 59, Part 3. When I said we're going to go on, but I stopped Part 2, so I was confused by that. First, I'm going to rewrite this instead of having fraction with the denominator square root of x plus 4. I'm going to bring it up to the numerator, make it x plus 4 to the negative 1 half. Okay, so same thing. Find u, and we're going to find x in terms of u, and then we're going to find du and dx. So I'm going to use u as my inside function. Okay, so u is going to be equal to x plus 4. And I like to just go right down and find out what x is. So if u is x plus 4, then x equals u minus 4. And now we're going to do du dx. So I'm going to take the derivative of this, just kind of like what we did if it was y equals x plus 4, we'd have dy dx. There's other ways we can do that, but 1 du dx equals, this is just 1. Okay, so we don't need to write anything down there. So here's our inner function, here's what x is, and now I want to know what du is, and I want to know what dx is. So du equals, multiply both sides by dx, so it's 1 dx, so we just find out, hey, du equals dx. Alright, 1 du equals 1 dx. That's a step I could have done in there, and we'll do that more on day 60. Okay, so I'm really just multiplying both sides by dx. Okay, so the next part is just going to be a lot of algebra. So rewrite the entire integrand as a polynomial or polynomial type of function in terms of u. Then anti-differentiate. So we have the integral of parentheses, but I need to do another parentheses. Every place C and X, I'm going to put a u minus 4. Just put brackets over here, plus 1. Brackets, what's x plus 4? Okay, that's u. That was nice. And then we knew du equals dx. Okay, next step, I gotta simplify. So inside 2u, and 2 times negative 4 is negative 8 plus 1 is negative 7. And we still have our u to the negative 1 half. And again, what's my goal? Make it look like a polynomial or polynomial type. So now let's take this u to the negative 1 half and distribute it through. And so we get 2u times u to the negative 1 half is going to be 2u to the 1 half. So again, I'm just taking this and distributing it through. Minus 7u to the negative 1 half du. Okay, and that should be in parentheses. I know sometimes in the notes that's not written like that. Even in some of the books you'll find it's not written like that. Okay, well now I have enough, I can just write that. That's really an integral of a difference, it's the difference of integrals. So now we can take the antiderivative. So for this, 2u add 1, we get 3 halves, divide by 3 halves, which is the same as multiplying by 2/3, minus 7 add 1, which is going to give us positive 1 half, divide by 1 half, which is the same as multiplying by 2. I like to put it in front. You can do it either way. You can still write it as a fraction plus c. Okay, so if you wanted to write that one as a fraction, it would be 2u to the 3 halves divided by 3 halves minus 7u to the 1 half divided by 1 half. Oh, that's supposed to be 1 half. 1 half and then plus c. Those are the same things. Okay, some people, and so you don't get confused, you will make a mistake if you're not paying attention. You raise 3/2 power, then you multiply by 3/2. So if that's the case, do this way. So you just 3/2 and put 3/2 in the denominator. Okay, well either way, now every place I see, let me just multiply those out, and then, so I'm going to get 4/3 u to the 3/2 minus 14 u to the half plus c. That's supposed to be 14. 2 times 7. And now every place we see u, we're going to put in our inner function x plus 4. Okay, and this is the pattern over and over again. 4/3 x plus 4 minus to the 3/2 minus 14 x plus 4 to the 1/2 plus c, and just so you can visualize what we're doing here, putting in x plus 4. Okay, it seems like a lot. It's not that bad. Alright, let's take a peek at this last example. Okay, find the value of the integral of x times the square root of 2x plus 1 dx from 0 to 4. So this is new because we have the intervals from 0 to 4. Okay, but our process is still going to be the same. And I think it's important to, let's write this from 0 to 4 of x times 2x plus 1 to the 1/2 dx. Okay, so now what were we taught? Let's find, hey, what's our u? Use the inside function. That's going to be 2x plus 1. I always like to do, hey, what is, well, let's take the derivative. So derivative du dx, again, that's 1 du dx equals 2. So now du equals 2 dx. Therefore, dx equals 1/2 du. Okay, and then lastly, we know u equals 2x plus 1. So now I'm going to subtract 1 from each side, and then we're going to divide by 2, which I'm going to show is multiplied by 1/2. Okay, so now our goal is to write everything in terms of u. And there's one new step here that we haven't done yet. So let's first set it up. So it's now going to be the integral. What was x equal to? X was equal to 1/2 u minus 1. I'll look over here. There's my x. 2x plus 1. That's nice. That's just u. U to the 1/2 power. And what's dx equal to? 1/2 du. Okay. What's the one thing I'm missing? 0 to 4. The 0 to 4 for intervals is based off of x. Okay, well, we're not talking about x, we're talking about u. How do they relate to each other? Well, u equals 2x plus 1. So u equals 2 times 0 plus 1, which is going to be 1. And u equals 2 times 4 plus 1. And that equals 9. So now our integral is going to look like this. So something we didn't have to do before, but we'll have to do for any time they give us a definite integral. Okay, and now the process is the same. Simplify it, make it look polynomial-like, and then use the fundamental theorem of calculus. Take the integral, but then evaluate, so capital FB minus F of A. So let's go through and do that. So what am I going to get here? So first of all, 1/2 times 1/2 is 1/4. I'm going to take that outside. Get rid of the constant. So we're still from 1 to 9. And then I'm going to go through, well, I'll just write it out. U minus 1 times u to the 1/2 du. Now let's distribute that. And I probably could have skipped that step. That's okay. So let me just go to another marker. 1/4. Let me write these down. So okay, here. Now, all I'm doing is fundamental theorem of calculus. So the 1/4 stays. What is the antiderivative of this? That's going to be u to the 5/2. And I'll do it by dividing by 5/2. minus u to the 3 halves divided by 3 halves, and then we're going to evaluate this from 1 to 9. Okay, well let's first simplify this. So hopefully we see it's dividing by 5 halves, same as multiplying by 2/5. So just whether you jump right to this step, that's fine, but you just have to pay attention. Just have to pay attention to was I dividing by a fraction, or did I already do it? Okay, and now let's put in the 9 and then put in the 1. We're simplifying. Okay, we put a 9 everywhere, and they made it easy for us. First of all, we don't have a plus c because it's a definite integral, because we know it's on the interval from 1 to 9. Square root of 9 is 3 to the 5th power. Actually, I'm going to leave that as a power, and then we can use our calculator, and we'll check to make sure the answer is, so this is going to be 3 to the 5th minus 2/3. This is 3 to the 3rd, which is 27. That one's easy. What's this? 81. That's 243. All right, and minus. Oops. So hold on. That should be parentheses. This should not be there because that's going to be at the end. Minus parentheses. Square root of 1 is 1, to the 5th is 1, so it's just 2/5 minus 2/3, same thing there. Then the bracket. Okay, and when I do all this out, we should get an answer of 19.867. And I'm just going to do this on the calculator just to show that we can verify that the integral from 0 to 4 of x square root of 2x plus 1 dx gets us this 19.867. Okay, but this is using U-substitution. It's whenever that pattern recognition doesn't work. And why doesn't the pattern recognition, when I go to that inside most 2x plus 1, that would be my g of x, but when I take the derivative of it, I get 2, and I can't go back. I can always multiply by a constant. I can't multiply by a variable or a variable in the denominator. So it has to be exactly the right power. So let's put this into the calculator to check. And as we see, we get the same answer. Okay? So if you ever have definite integral, you can always check that. And again, that's all I had to type in on the calculator, hit the math button, go down to the FINT, and put in the function. The interval was 0 to 4 to begin with. We only changed it 1 to 9 when we had to do the U-substitution. So look at all the work I had to do. And I kind of cheated at the end. I didn't even use the calculator to do that arithmetic. So, but that's U-substitution, and it's not that bad. So you'll be able to practice on day 59.